Understanding Scud Clouds versus Private Funnel Clouds, sponsored by Emergency Operations of West Virginia. In Western Virginia, a meteorological perspective, one of the most common mistakes made by the public during severe weather is confusing Scud clouds with funnel clouds. While both may appear intimidating, they are very different atmospheric phenomena. Misidentifying a harmless Scud cloud as a funnel cloud can create unnecessary panic, overload emergency communication systems, and contribute to the spread of misinformation on social media. Learning to distinguish between the two helps improve public safety while allowing legitimate, severe weather threats to be identified more accurately. What Scud clouds actually are: Scud clouds, technically fractus clouds, are low, ragged cloud fragments that form in the turbulent inflow region of a thunderstorm. Key professional characteristics: no rotation, formed from moist air being lifted, cooled, and shredded in storm inflow or outflow boundaries, appear chaotic, torn, and shapeless, often move rapidly in different directions, frequently appear under shelf clouds, near heavy rain cores along gust fronts. Scud is essentially cloud debris in turbulent air, not a structured atmospheric circulation.
Down to the weather, take a look at this. People in Atlanta got a real scare when they saw this huge menacing cloud. It looks like a tornado, but it turned out to be something harmless. The National Weather Service says it's actually a Scud cloud. Chris Mulcahy can explain more about those Scud clouds, and that really does look scary, Chris.
Yeah, this is definitely the most tornado-like Scud cloud that I have truly seen in my career, just because you have to look very closely to make sure that it's not rotating. And there's some other factors that are usually entwined about this, but this is actually technically called a fractus cloud as well. So a fractus cloud just literally just means a piece of a cloud, and some of them are a little bit scarier than. Check this one out. This is an example. This is actually about 25 years ago that this photo was taken. This is another Scud cloud off in the distance. It looks like kind of like a tilted tornado. Nope, just a piece of a cloud. Here's a classic example. It's usually just the little appendage that comes down from a storm. So the key here is every time you see something kind of lowering, if it's not rotating, it is not a funnel. It is just a piece of a cloud or a Scud cloud. And now you know. Thanks a lot to the National Weather Service as always. This is where I got some of these photos. We don't have any nearby ones in our system, so it's always nice to get some of those sources there as well.
What a funnel cloud actually is: meteorological definition. A funnel cloud is a rotating, organized column of air that extends downward from a thunderstorm cloud base, usually from a mesocyclone, a rotating updraft within a supercell thunderstorm. Key professional characteristics: rotation is present. This is the defining feature. Forms from a strong updraft with vertical wind shear, is part of a mesocyclone. Or developing tornado circulation, has a well-defined coherent shape, often narrowing toward the ground. Becomes a tornado only if it reaches the ground. In meteorological terms, a funnel cloud is a visible expression of a dynamic rotating vortex column where pressure drops inside the rotating air cause condensation. Difference: rotation versus propellant. Turbulence: this is the single most important distinction meteorologists use in the field. Funnel cloud or organized rotation: air is spinning around a central vertical axis. Structure is coherent and sustained, associated with mesocyclones. For rotating storm systems, Scud cloud or chaotic airflow, air is being torn and stretched by gusts and inflow. Movement is random, erratic, and non-rotational, no organized atmospheric vortex exists. A simple way meteorologists phrase it: if it rotates, think funnel cloud. If it raggedly scuds, think scud cloud. Shape, structure, and behavior differences: funnel cloud, smooth or rope-like appearance, often vertically aligned, and narrowing may persist in one area for minutes, can descend, and tighten if intensifying. Scud cloud, ragged shredded appearance like cotton torn apart look, constantly changing shape, moves in multiple directions at once, appears and disappears quickly where each forms in a thunderstorm. Funnel clouds form in supercell thunderstorms, strong mesocyclones, rotating updraft zones, or updraft-downdraft interaction areas. They are tied to storm, scale dynamics, and wind shear. Scud clouds form in gust fronts, or outflow boundaries, rain-cooled air under storm bases, inflow regions feeding warm, moist air into storms. They are tied to localized turbulence and moisture condensation, not storm rotation. Why people confuse them: even trained observers can confuse scud with funnel clouds because both occur under dark storm bases, both can hang low, and appear descending. Rain curtains nearby distort visibility. Rapid cloud motion creates optical illusions of rotation. However, meteorologists rely on one critical diagnostic: continuous consistent rotation equals funnel cloud, fragmented inconsistent motion equals scud. Practical safety interpretation: from a weather safety standpoint, funnel cloud observed in a rotating storm equals potential tornado development. Scud cloud equals no direct tornado implication by itself. However, a caution used in forecasting: scud can sometimes mask or resemble developing lowering cloud bases, so observers are trained not to dismiss suspicious lowering features too quickly in severe storms. Conclusion: funnel clouds are organized, rotating atmospheric vortices tied to severe storm dynamics. Scud clouds are disorganized fragments of cloud material shaped by turbulence and wind shear without rotation. For many members of the general public, interpreting severe weather can be challenging because they have not received formal education or specialized training in meteorology, atmospheric physics, or the interpretation of weather models and radar imagery. During severe weather events, visual observations alone can easily become misleading. Features such as scud clouds, wall clouds, and funnel clouds often appear similar to an untrained observer, especially when viewed from a distance or through heavy rain. In addition, the psychological effects of stress and heightened adrenaline can significantly influence perception. Under stressful conditions, the brain naturally shifts into a heightened state of alert, narrowing attention and increasing the likelihood of misinterpreting rapidly changing cloud formations. What may appear to be a tornado to one observer may, in reality, be a harmless scud cloud being carried by turbulent winds beneath a thunderstorm. Accurate weather interpretation requires more than visual observation alone. The EOoWV ERT command and meteorologists integrate numerous sources of scientific data, including Doppler radar, satellite imagery, surface observations, upper air analysis, atmospheric soundings, numerical weather prediction models, and storm dynamics to evaluate whether a storm is exhibiting organized rotation or simply producing visually deceptive cloud features. Because of this comprehensive scientific approach, it is essential for the public to remain calm and rely on trusted meteorological resources rather than drawing immediate conclusions based solely on what they observe in the sky and the interpretations of Facebook users. One of the greatest challenges in today's digital environment is the speed at which information spreads across social media platforms, particularly Facebook. Photographs, videos, and eyewitness reports can be shared with thousands of people within minutes, regardless of whether the information has been verified. As a result, rumors, misidentified cloud formations, and inaccurate reports of tornadoes or severe weather can spread much faster than professional verification can occur. While social media can be an effective tool for sharing timely information, it can also unintentionally amplify misinformation and create unnecessary fear, confusion, and panic within communities. The Emergency Operations of West Virginia encourages the public to develop sound situational process awareness by seeking information from reliable and scientifically credible sources. Before sharing reports or photographs of suspected funnel clouds or tornadoes, individuals should compare the information with official weather products, radar data, and statements issued by professional meteorological agencies. Remaining informed through trusted sources not only improves personal decision-making, but also helps protect families, emergency responders, and entire communities from the unintended consequences of misinformation. Accurate weather communication is a shared responsibility, and informed observations contribute significantly to public safety during rapidly evolving severe weather events. Thanks for watching EOoWV.